Hi everyone, my name is Marat, and I want to start my channel LabTalk with scientists from the different countries, from the different fields, about their life, about their research. And first one will be Kacper. He is from the Toruń University. So, hi everyone, this is Kacper. Kacper.
Kacper, yes.
Yeah, he he is a microbiologist. And firstly, I want to say hi for everyone.
Wait, I'm a biologist, to be honest.
Oh, you biologist.
I'm a biologist,
So-
and to be more precise, I'm working in the tissue culture lab. So even I can say that I'm an immunologist.
Okay.
So I'm working with cells of immune cell, cancer cells, or cells from the guts or wherever, every single part of your body, even the brain.
Okay.
Cells, yeah. I was working with such cells when I was working on the glioblastoma and neuroblastoma cells. So,
Okay. So let's start from beginning. Introduce yourself. You are. Where are you from? What the city? Where are you studying? Where are you working?
okay, so I'm Kacper Roszak. I'm a PhD student, and also I'm the employee at the ICNT, which I don't know how to make this acronym longer in English.
It's the International Center of New Modern Technologies.
Model technologies, yeah, probably. So yeah, I'm working here, and in here I'm responsible for the microbiology. So that's why probably you
Yeah.
thought that I'm
Yeah,
microbiologist.
that's why I thought about it.
But right now I have a switch to get back to my business and work in the tissue culture lab because I'm a specialist in it, not in the microbiology. I was doing this as a side project, let's say.
Okay.
And the tissue culture lab is my, let's say, the best thing which I can do. And where I'm living, well, I'm from small village next to the Toruń, so this is not that I'm from different part of the Poland. I have approximately 50 kilometers to Toruń, so this is not a big deal.
Okay.
But normally I have an apartment, renting apartment, to
Okay.
be more precise, in Toruń, and I'm living in here. So like 99%
Of
my
your
time,
life?
of
Yeah,
my life I'm spending in Toruń.
Okay.
So if somebody is going to look for me or something, I'm in Toruń.
Okay. So that's super cool. Actually, I'm so far from the biologic and everything. I mean, it's the cells and brains, and the cancer. So first question is, how did you decide to go to this field? It's a really interesting, I think, for everyone. How do you decide to go there?
Actually, this is pretty funny story because at the very beginning, very beginning, when I was starting studying, I had a big dilemma because I was about actually to study the finances,
Okay.
not the biotechnology.
It's completely different.
Completely different. I was even enrolled in the the applications and those things. So I was actually on the list of the students on the finances profile, but I wrote to the dean that, come on, this is actually not my cup of tea. So could you change this somehow? And immediately I was switched to the biotechnology because obviously biotechnology is not as popular as the finances.
Yeah, it also is much easier than finances, right?
Actually, I'm not sure about it, but how I ended up in the immunology, well, the story begins at the second year of my study when I was on the bachelor, and I was enrolled in one project with Dr. Ákos Nemec. He was the supervisor of this project. And obviously there was a pandemic, I was newbie, so I decided that okay, I'm going to have some experience, gain something, do something more just to improve something. And because of it, I started to work in the molecular biology, and I find out that this is super complicated, especially when you are working with receptors. At that project we were working in the acetylcholine nicotinic receptors.
Okay, it's super hard to pronouncing it.
Those receptors are responsible for for example, muscles contractions and those things. So, and also because of the nicotine, it is associated with addiction to the nicotine.
Exactly.
And in this project, this project was focused to find out some sort of like human version of a binding, extracellular binding part of this receptor, just to mimic it, and maybe in future to create some sort of drugs to overcome the addiction to the nicotine. So it was ambitious project.
But actually, it's a really nice ambition.
Yeah, but doctor is pretty ambitious, so yeah, that's why probably. And I was just, assistant newbie, let's say something like this. So I was.
Did you success?
This project we success at some point, but obviously it was too complicated to conduct it in 1 year because he was so ambitious. But we were happy about the results. And because he is working in the biochemistry department, I was enrolled somehow in the biochemistry, and also I find out that the head of this department, she's working, the professor, she's working with cells. Obviously, during this project, I have the opportunity to work with the cells, but as you can imagine, when I was newbie, and obviously it was super complex project, every single step was like, okay, Kacper, you can do this, not screw up, just be patient, be careful.
It's take a time.
Take a time, obviously. Oh my God, this reagent is going to be trust. Okay, Kacper. Yeah. So it wasn't like. I'm scientist. It was rather like, okay, I'm not going to do this because I can screw up. Okay, so I decided to maybe improve those skills because I find that okay, this is wearing the whole coat, new coat, not the white one, mostly the physician one. Gloves, you need to be sterile. You're working with cancer cells and something like this. Or even in the future, you can work with spheroids. I don't know if you're familiar with this.
Steroids?
Spheroids.
Spheroids.
This is the clumps of cells, usually the same type of cells, because if there's not, this is the co-culture. But spheroids, when there are clumps of cells, and there's, for example, 10,000 cells, like that, they behave differently, and it mimics the, let's say, organism-like environment, because obviously when you have, for example, skin, there are layers, and when you apply some drugs, obviously this drug is not going to go direct to every single cell at once, so that's why spheroids are better, because they mimic somehow this environment. So that's why I decided to work with the cells, just to somehow make it fancy-like, let's say. And because of the fact that most of my master degree, my bachelor degree, and few projects in which I was enrolled, they were focused on the immunology. We were conducting studies on the purinergic signaling, which is strongly associated with immunology. This is like ATP, adenosine triphosphate, and those molecules which are metabolized from this one molecule, they are associated in their.
I cannot ask anything because I'm just so far from you.
Yeah, I can imagine. Because, like if you are going to say something about chemistry, I'm going to be like.
Yeah, exactly. I'm feeling myself right now. Same.
Yeah. So in my case, I was studying the purinergic signaling when I was on the bachelor and the master, and to describe it easier maybe. When you have the ATP, it can be metabolized to the ADP, AMP, or the adenosine, and that's why this is called purinergic signaling, because this is the purines, and the purines, when they are detected by the receptors of cells, they usually differently it depends on the cells, obviously, but they differently respond to it, and most of the immune cells have the receptors which are associated with pro-inflammatory response and anti-inflammatory response. And this is pretty funny with ATP, ADP, AMP, and adenosine, because ATP is pro-inflammatory, and at the very end, adenosine is anti-inflammatory. So when you are focused to somehow manipulate the environment in the context of the immunology, then you can just switch from the ATP to adenosine, increase this metabolism, or somehow make it better. We had the enzyme which we were used to do this. And obviously there was some modification of the enzymes, plenty of different applications, for example, for the brain, for the vessels, right now.
So you working with a real brain? I mean, you get some brain from human brain?
No. Those were cells. Neuroblastoma, SHSY5Y, I think, because the cells are not usually right like neuroblastoma. They just prefer to write it completely, out of mind. So that's why I was working with neural cells, and I remember that those neural cells were completely to work, because as you probably know, there's a problem with replication of the neural cells.
That's exactly,
when you're working. So those cells are normally, that's why I said neuroblastoma, which means there are cancer cells. Yeah, but you can differentiate them to the like normal cells, like neural normal cells. But when you differentiate them, they do not replicate. So as far you differentiate them to the neural cell, they're stopped and you can do the experiment. But there's a slight problem. First of all, the protocol, this is approximately 2 weeks to differentiate them. If you screw up anything, then obviously you are going to receive the outcomes at the very end. Then the substance which we were using to differentiate these cells, this is the retinol, and retinol is the light sensitive substance, and it degrades in the light, so you're working in the darkness. So just to make it easier, you are working in the aseptic environment, and also you are working in the dark. So and at the very end, of course, you have some cells, you're happy that you have those cells, but for example, the number of cells is not enough for the experiment.
And you need to repeat everything
from the beginning. And you need to repeat everything. So that's why I say that it was super hard to work with, because for example, right now I'm the different department, because that was the biochemistry, and because I was working in the immunology mostly, I switched to the PhD to the immunology department. And right now I mostly work with immune cells and cancer cells.
So it's easier than you work?
Much easier. If you have the typical, let's say typical because there's no standard, but typical cancer cells, it works like, you have 500 cancer cells on plate, so normally this is not enough cells. You need contact to proliferate. But cancer cells, come on, I can do whatever you want. 1 week without changing the media, I'm going to survive it. As a good example, when you are working in the in vivo, we are working...
in vivo means inside the human body, right?
Yeah, it means that, for example, in the animals.
In the animals.
So when you are taking the cancer cells and apply this to inject those cancer cells to the...
1 second, the cancer cells from the animal?
Yes, you can, because normal cells on which we are working, they are from the bank. They are like the bank ATCC, I think, American Tissue Culture something. I think it was like that.
It's like a shop.
Yeah, like a shop. Actually, yes. You are just scrolling and searching for cells which you want for your experiment, just like that. And one cell line is approximately 2,000, 3,000 zlotys or something like this. And you can just take the cells, modify it, work with them,
Oh,
treat them.
You can do. You can make it from the normal cells to the cancer cells by yourself.
I can do.
Oh, really?
There are modifications to do this.
I didn't know that. It's like a fantastic, like a.
When you conduct the tissue culture lab, obviously there are two different ways to obtain the cells. First is from the bank. So this is the easy way.
Easiest way.
Yeah, you are buying.
But it's an expensive way.
Yeah, both of them are expensive. So
Okay.
if you compare the struggle in the time and the amount of the reagents which you need to use to make them immortal, let's say, because we have something like Hayflick limitation. Maybe you heard about it, maybe you know. So Hayflick limitation for the cells, this is the phenomena that the normal our cells, for example fibroblasts, let's say, when they proliferate, they have a limit.
Yeah, they can die at.
For example, 20 duplications, they are going to die. This is associated with the shorting of the chromosomes and metabolic and epigenomic modifications. But this is completely normal. On the other hand, cancer cells do not have something like this.
Oh, really?
They can survive with this. They just proliferate. They mutate every single time. So for them, this is like, okay, we are just going to survive.
Really?
That's why they create most of the cells which you have in the bank. They are the cancer cells because they are easy to maintain. It's easy to froze, and then you can sell it and sell it and sell it.
Okay.
And you can make them immortal by obviously genetic modifications, or you can just take the normal tissue. Let's say normal tissue. Then you are treated them with the chemicals, with the UVs, just to make them cancer.
Okay.
So every cancerogenous substance, obviously you are not going to work with the normal tissue, so it's going to behave differently, but you have the immortal cell line. And yeah, it's time consuming, annoying. On the other hand, because obviously you are buying the cells, there's a cancer, you can work on the primary cells, which means that those cells are going to live, for example, 20 passages, so 20 replications, let's say. We are counting the
duplications.
I don't want to say the duplications, because the duplications of the cells, this is approximately 16 hours, something like this.
Okay.
So this is 1 day. And we are doing the passage twice in the week, something like this. So this is not like the duplications, but rather than just changing the media, taking those cells, reduction of the population to the other bottle, and they're just growing, and they're happy.
I mean, the cells happy or the supervisor happy?
Both, if they are living, yes. Well, sometimes it happens that those cells are. We have even our motto that the cells differently behave, and it is associated with the moon phase, because it is sometimes unpredictable how cells are going to behave.
Really?
For example, once I have a cell line, and those cell line, this is raw cells. Raw 264, I think this is something like this. Macrophages. Macrophages. And those cells are so annoying. This is like, I don't want to be, rude something, but girl with a period, to be honest. At one point they are behaving completely normal, and then, for example, just start to dying. And I was like, why guys you are doing this? I have an experiment planet. They're like, bye-bye, hello.
Okay. So it's super hard to work with the cells. I mean, they are living, they can just die.
You can contaminate them.
They can contaminate them.
And if you contaminate...
Do you have it some time? I mean, maybe you get frustrated, maybe, and you want to quit from this, from the biologic stuff.
Well...
Return back to the finance.
To finance now, but because biotechnology, to be more precise, is my passion, obviously, and I want to work on the academia, probably just as most of the PhD students. But I had the feeling that the tissue culture lab is too annoying for me. Because obviously when you're working in the, for example, biochemistry or working in the molecular biology, you are focused on particles. For example, in the biochemistry, you are working with enzyme and you are checking the enzyme in different conditions, different modifications, and you don't care about the cells that you need to be here at weekend just to change the media because they need to live just like normal animal, let's say. This is the living being actually. So this is pretty annoying, and obviously they have their own behavior, let's say feelings, as I said, moon phase. And on the other hand, you are working with an enzyme in the biochemistry, so you are putting this in the freezer, going for the vacation, then you are back and checking the activity. Oh, it decreased. I was in the vacation 2 months. Okay, never mind. So, like, compare this two. But I think that working with tissue culture lab is self-rewarding, let's say, because I know that in future it can cause, for example, that I'm going to be enrolled in project and I have the opportunity to invade some treatment or just check some materials if they are not toxic.
At least you are being a piece of something bigger.
Yeah. Because in biochemistry also, because in biochemistry I can create this drug. But in here I'm just testing it if this is toxic or not, and you know, this is like a fancy one. And obviously there are like photos of the cells, and this is like cute one.
Okay. And my next question will be, maybe you know the different field of the research. Maybe you dream about it. I mean, the different field, what you dream about this field, you know, maybe some.
At the very beginning, I wanted to be a chemist, like the very, very beginning. But unfortunately, I had pretty bad teacher in the high school, so it changed everything. Then, obviously, finances somehow appeared because my friends were joking around that, Kacper, you are pretty good at math and pretty good at the biology, and you know, you cannot just connect this. So I was like, finances, maybe I'm going to have, you know, better salary or something. And somehow it pushed me a little bit to the finances, but then I was like, what am I going to do working bank? No, this is not something for me. This is not my cup of tea, absolutely. So I ended in the biotechnology. And maybe in biotech, if I had the different, let's say, profile to choose or something, no. I'm working with medical things, because obviously working with cells. And I wanted to be in medical field, but not as a doctor. I don't want to treat people.
You want to be like a researcher.
Yeah, it is better to be a researcher working with cells.
They not speak.
They don't speak, not complain, not as much. And I don't have as much responsibility as a doctor. You know, I'm just working with the cells.
I understand.
Obviously, I can have.
But anyway, you will be doctor at least PhD.
Yeah, something. So this is not that bad, to be honest.
I got some joke at home because my parents want to have a doctor at the family, so I'm saying I will be a PhD, so it's the same like a doctor. So I'm a different doctor, but I'm still a doctor.
I'm joking that in my small village, when I'm going to receive the PhD, if I'm going to the small shops like those, you know, near to your house, conducted by one family, for example, the whole queue is going to be like that because I'm a PhD.
Like a Jesus,
yeah, like a Jesus or something. Or I am going to have a monument or something in the middle of the town because I'm going to the first one with a PhD.
Exactly.
So yeah.
Oh, that was super nice conversation, I think. And now I think we can finish our a small interview. I don't know how it's called. It's like a small interview. Yeah.
If you have any question, you can just write or something.
Yeah, I will left the contacts in the end of this video. And also what subscribe? I don't know what to say.
Subscribe him.
Subscribe. Yeah, thank you. Thank you.